Hello, my amazing students. This is Mrs. A, and I love math. And tonight we're talking about lesson 33 in your Saxon Orange Book. We're talking about the product of prime factors. So the first thing we need to do is figure out what that word means. What is prime and what is composite or composite? Both ways are correct. I've heard it both ways. So, composite numbers are numbers that are composed of other numbers. They're made up of other numbers. So 6 is 2 times 3. Therefore, 6 is a composite number because it is made up of other numbers besides itself and 1. Okay, 35 is made up of 5 times 7. Therefore, it is a composite number. And 17 is not. 17 can only be factored 17 and 1. Therefore, 17 is a prime number. So the definition of prime is any number greater than 1 that which cannot be factored except by itself and 1. So we're going to work with prime and composite numbers. Okay, so I wrote out the definition so we could go over it a little bit more succinctly. A prime number is a counting number greater than 1 whose only counting number factors are 1 and the number itself. So a prime number can only be split up into itself times 1. In other words, there's no other way to break it up. So our first example is to express 80 as a product of prime factors. So what I'm going to do is every factor has to be a prime number. So I'm going to start with 80. And I like to do it this way. There's several different ways you can do it. I like to do it this way. I divide by the smallest prime number that will go into it evenly is 2, right? I know it's 2 because it's an even number. So I'm going to start with 2. And 80 divided by 2 is 40. So I'm going to divide it by 2 again because 2 goes into it evenly. And I get 20. 20 divided by 2 is 10. And 10 divided by 2 is 5. So 80 is 1, 2, 3, 4, 2 to the 4th times 5. Is 80. So we would say 80 equals 2 to the 4th times 5. And that would be expressing 80 as a product of prime factors. You see, each factor is as low down as it can go. It cannot be divided by anything else. The next example says 147 as a product of prime factors. Now, 147 is not divisible by 2. But when I look at it and I remember my divisibility rules, it is divisible by 3, isn't it? How do I know? 1 plus 4 is 5, plus 7 is 12. 12 is divisible by 3, therefore 147. Remember, the 3 rule is we can add up all the digits, and if the sum of the digits is divisible by 3, then so is the number. So I'm going to start. Since 3 is a prime number, you can't divide 3 up by anything else. I'm going to divide by 3. 3 goes into 12 4 times. And then I have, when I take out the 12 out of the 14, I have 2, so 27. 3 into the 27 is 9. And then 49 divides by 7, leaving 7 left. So now I've got 3 times 7 squared. So 49 equals 3 times 7 squared. And that's what they mean by a product of prime factors. Okay, this second part of lesson 33 is about statements about unequal quantities. So we're going to write an equation, but when you look at the words here, it almost sounds like it's not an equation because it has a less than in it. But these are written as equations. We just have to learn the trick. Okay, so twice a number is 42 less than negative 102. Find the number. So we're not going to write this as an inequality because this less than means that I'm going to start with this number and take 42 away from it. So let's say twice a number would be 2 times n is my equal sign. Is 42 less than negative 102? Did I accomplish it? Okay, so twice a number is 42 less than the number negative 102. Find the number. So that means find the n. So these two are both negative, meaning they're going in the same direction. So I can add the two negative quantities together and get negative 144. Okay, so twice n is negative 144. Divide by 2 to get the n by itself. And n is equal to negative 72. Wasn't that nice? Not nearly as hard as it looked when you saw it in the words, is it? Okay, so this next example says 5 times a number is 72 greater than the opposite of the number. Find the number. So we're being interpreters here, aren't we? We're interpreting these words to put them into an equation so that we can solve it. 5 times a number would just be 5 times n, or 5n. Is my equal sign. 72 greater than the opposite of the number. The opposite of the number would be negative n. And 72 greater than the opposite of the number. Okay, let's see if we did it. 5 times a number is 72 greater than the opposite of the number. Find the number. So let's start by getting all of our n's on one side. I have a 5n over here and I have a negative n over here. What if I add an n and add an n? 6n equals 72. Therefore, n equals 12. Let's check it, okay? So 5 times 12, and 5 times 12 would be 60, is 72 greater than the opposite, or negative 12, plus 72. Isn't that equal to 60? And it works. Okay, so this is our next to the last example before we start our practice problems. If the sum of twice a number and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number. So it's getting a little bit more complicated, isn't it? Right? So we're going to start with if the sum. That means we're going to add two things together. And then it's going to tell us which two things we're going to add together. If the sum of twice a number and, that's where we put the plus sign, negative 14 is, that's our equal sign, is multiplied by 2. That's not our equal sign. Is multiplied by 2. So now we're going to take this whole thing and multiply it by 2. That's why I always read things twice, right? The result is, there's my equal sign, 12 greater than the opposite of the number. 12 greater than the opposite of the number. Okay, so now let's see. Let's read it again. Make sure we have it. If the sum of twice a number and negative 14, twice a number and negative 14, is multiplied by 2, so there's the times 2 in the big bracket to keep it all together. The result is, that's my equal sign, 12 greater than the opposite of the number. I think we've got it. All right, so now we cannot add these together, but we could distribute. We could distribute the 2 through. So 2 times 2n is 4n. 2 times negative 14 is negative 28, is equal to negative n plus 12. Okay, so now I've got n here and n there. Don't I need all my n's in one place? So I'm going to add an n to each side. Now what I'm going to do is make a little bit of room up here. so I have some room to answer the problem because I'm out of boards here. So let's take this. Let's add the n to both sides. So we're going to have 4n minus 28 equals negative n plus 12. And then we're going to add in to get rid of that one. And we get 5n minus 28 equals 12. Now we want to get this n by itself. So we want the n term by itself, so we'll add 28 and add 28 over here. So now let's see what we've got. 5n cancels equals 10 carry 40. So n equals 8. Okay, so since I ran out of board, let's go back and look at the answer. Okay, it says if the sum of twice a number, so twice 8 would be 16. 16 and negative 14 would be 2. If that number was multiplied by 2, that would be 4. The result is 12 greater than the opposite of the number. The opposite of the number is negative 8 plus 12 is 4. So we had 4 on one side and we had 4 on the other, and it works. Okay, so we have one more practice problem before you go do your, one more example before you go do your practice set. Okay, so 5 times a number is 21 less than twice the opposite of the number. So 5 times a number is 21 less than twice the opposite of the number. Always read it twice. 5 times a number is 21 less than twice the opposite of the number. I'm sticking with that. So we 5n. 2 times negative n is negative 2n minus 21. We have an n there, so we want to get them all on this side. So plus 2n, 7n equals negative 21. Divide by 7 on the bottom. N equals negative 3. Okay, so let's check it. 5 times a negative 3 would be negative 15 is 21 less than twice the opposite. So if negative 3 is the number, the opposite would be 3. Twice 3 would be 6. 6 minus 21 is negative 15. And we get negative 15 on both sides. Therefore, n is equal to negative 3. Checks out. Okay, this is your first practice. So I want you to read it, copy it down, and pause your video. Find a number such that 8 times the number is 36 greater than the opposite of the number. So find a number such that 8 times the number is 36 greater than the opposite of the number. Find a number such that 8 times the number is 36 greater than the opposite of the number. I think we have it copied correctly. So we've got a negative n and an 8n, but we only want n's in one place. So let's add an n and add an n. We have 9n is equal to 36. That means n is 4. Okay, let's check it out. Find a number, 4, such that 8 times 4 is 36 greater than the opposite of the number, which would be negative 4. Negative 4 plus 36 is 32, and 8 times 4 is 32, so it works. This is our second practice problem, so I want you to copy it down and then go do it. If the sum of a number and 6 is multiplied by 2, the result is 10 greater than the number. Okay, so the sum means add. So we're going to add two things together. If the sum of, now they're going to tell you which two things to put in here, a number and 6 is multiplied by 2. So we're going to do that. We're multiplying the whole sum by 2. Then the result, that's my equal sign, is 10 greater than the number. Okay, read it again. If the sum of a number and 6 is multiplied by 2, the result is 10 greater than the number. So 2 times n plus 2 times 6 is 12 equals n plus 10. Subtract n on that side. Okay, so we've got 1n plus 12 is 10. Subtract 12, and n is equal to -2. So n is -2. Let's check. Okay, if the sum of a number, so this right here is going to be -2, isn't it? Is multiplied, so these two added together is 4 times 2 is 8. So I have 8 on this side of the equal sign. And then I plug in -2 right here. -2 plus 10. Don't I have an 8 on the other side? And it works. Okay, so we're going to write 108 as factors, prime factors. So we're going to say divide by 2. We get a 54. Divide by 2. And we get 25 would be 50. So this is 27. Divide by 3. Because 2 doesn't go in, but 3 does, doesn't it? We get 9, divide by 3, and divide by 3. So 108 is equal to 2 times 2 times 3 times 3 times 3. Now we could write 2 times 2 times 3 times 3 times 3, or we could use exponents and say 2 squared times 3 cubed. Last practice problem. We're going to write 400 as a product of primes. We're going to start with the lowest prime that goes into it, which is 2. And we're going to divide by 2. And we're going to divide by 2. And we can still divide by 2. Now we can't divide by 2 anymore. I'm going to divide by 5 because 5 is prime. And we are done. So we could say 400 equals 2 times 2 times 2 times 2, 2 times 2 times 2 times 2 times 5 times 5. Or we could shortcut that using exponents. 1, 2, 3, 4, 2 to the 4th times 5 squared. And that would be the product of primes. And this is Mrs. A, and may God bless your day.